Hello guys, today is another tea video, but it's a little bit different because I will need 50 degrees water. Now, how are you making 50 degrees water when you just have an ordinary kettle and you need 50 degrees water? Right, so pretty much you use math in a way that you need the average temperature to be 50 degrees water. So what I do is I'm doing a weighted average. So I take 1 liter of water, boil it up in the kettle, which will be 100 degrees because it will be boiled, and then I will need an X amount of tap water to make it 50 degrees water. Now, depending on how hot or cold is the tap water, it depends how many of that water I need. So how do I do this? So pretty much I have 1000 milliliters of 100 degrees water, X amount of milliliters of whatever degrees of tap water, which is around 20 degrees, but I have thermometer just to measure it, so I have an exact value. And then I multiply the 1000 milliliter by the 100 degrees, and then multiply the X amount of milliliter with the, let's say, 20 degrees water, and add these two together, then divide the whole thing by the total amount of water, which is the 1000 milliliters plus the X amount of milliliters. But how will it make sense? Well, because I mark it up as Z, that's the desired temperature. So you put the other side of the equation 50 degrees, and yeah, that's how it will be, and I will show you in a minute how does it look like in practice, because I have a little bit of a Yakura going on again and I need 50 degrees water, so I will be back in a sec. So I have the thermometer here, take it out carefully, and probably it won't focus on it. Oh, good God. Anyway, so I have a thermometer here, which I will put in the water and I can see how hot it is. So let's just move this way a little bit. Like that. So what I do, I make the kettle completely empty and rinse it as well, just in case it has a bit of lime scale in it. So as you can see, it is completely empty. And now, where is it? It's here. I take a measuring jug and I will put 1000 milliliters of water into it, which is quite a lot, considering that it will be just right up to the top. So maybe I just do it in 2 lots of 500, so it won't split over. So that's like 500 mils. Right, let's put it there and put this in and just wait a little bit until it cools down. I can see it going down already. Okay, it went below 20 degrees. Just leave it there for a little bit. I put this plastic thingy aside. Right, has it settled? Right, it looks like it has settled at 18 degrees. I don't know, probably you won't be able to see it. No, it won't focus on it because the background lighting. Anyway, it's settled at 18 degrees. 18? Yes, 18 degrees. Okay, so I know that the tap water today is 18 degrees. That's great. Let's put this 500 ml into the kettle. Get another 500 ml. That's that. Right, so I have 1000 milliliters of water in the kettle. Put this aside. Now, I won't turn the kettle on because you won't hear me. Oh, where is the pen? There. Let's go back to the math thing. I just quickly looked up the thing. Yeah, so who said that tea making is not full of fun? If not the battery, then it's the memory card that is full. So let me just write this. You can see me writing. You won't be able to see what I'm writing. In a minute you will though. So I have the tap water, which is 18 degrees. I will have X amount of that, and I will have the boiled water, which will be 100 degrees, and I will have 1000 ml of that. And now let's plug it in, and I have the desired temperature at 50 degrees. So let's put this down. So that's 1000 ml times 100 degrees plus X ml times 18 degrees divided 1000 ml plus X amount of ml equals 50. So that is how it looks like. So I have tap water 18 degrees, boiled 100. I will need X amount of the 18 degrees, 1000 ml I have in the kettle already, and I want 50 degrees water, and this is how it looks like. So let's get this started. So obviously we know that 1000 times 100, that's 100,000, right? So I have 100,000 there, hopefully you can see it, plus I have, so that's 18 multiplied by X amount, so that's 18 plus 18X divided by 1000 plus X, so that's 1000 plus X, and that equals 50, because 50 degrees will be the desired temp. Okay, so what we do now, because these two sides equal, we can grab this 1000 plus X and multiply the whole thing with it. So if we multiply 100,000 plus 18X divided by 1000 plus X by 1000 plus X, this will disappear, right? Because you divide it and then you multiply it with the same thing. So you will have on one side, you will have 100,000 plus 18X equals to something. Now we are multiplying both sides, so that will be 50 times the 1000 plus x. Now we can expand this, and let's carry on. That is quite a lot of zeros. And plus 18x equals, so if we multiply it out, 50 times 1000, that's 50,000. And you also have 50 multiplied by x, so you will have 50x. That's great! Excellent! So now what we can do, we can take away 50,000 from both sides, so that will leave 50,000 here, because 100,000 minus 50,000, that's 50,000. We still have the 18x here, and that equals, well, 50,000 minus 50,000, that's 0. So we only have 50x here. Now we take away 18x's from both sides, so it will leave 50,000 here, because 18x minus 18x is 0, it's nothing, equals 50 minus 18, so that's 32x's. 32x's. Let's carry on a little bit over here somewhere, because I have run out of space. So what we need to do now, we have to divide the 50,000 by 32, so we will know how many is equals to 1x. So that will come to 50,000 over 32. That will equal x. Oops, sorry, I'm not even showing. So that will be 50,000 over 32 equals x. Well, I can't really do that in my head, to be honest with you. So bear with me. I will be back with the calculator, because I can't do this in my head. Bear with me. So I'm back. I have the calculator here up and running. So 50,000 divided by 32. That comes up to, oh, quite a lot actually. It comes up to 1562, so 62 and half equals x. That means I would need 1.5 liter over 1.5 liter of tap water on top of it, 1 liter boiled water to make it 50 degrees. I am not happy with that, because the kettle can hold only 1.7 liters total. Okay. How can we reduce this? Let's see, we just do this whole thing again, but instead of having 1000 milliliter of 100 degrees water, let's just halve it. If we halve it, I would assume I would need only around 800 mils, because we halve everything. But let's just run the whole thing with that. So I have, because 100 degrees, 500 times 100, that will be 50,000, and plus 18x divided by 500 plus x equals 50. If you can see it, let's just make this quick. So that will leave me 50,000 equals that I will have plus 18x. That will leave me 50 times 500, that's 25,000, plus 50x, so that will leave us 25,000 here, equals 32x. So let's see, just to make it, how shall I put this so we can see it? So if we can make it, so let's just check. 500 times 100, that was 50,000. 50 times 500, that's 25,000. So that's so these are great. So these are okay. And then 25,000 was yeah, divided by 32. That will leave us 781 mil. If I multiply it, yeah, so pretty much I halve the 100 degrees water amount, so it will give me half of, I will need half of the tap water as well. Yeah, so that will be 781 and a quarter milliliter that I will need of tap water on top of the 100 degrees water. Right, let's put this into practice, yeah, let's do this. So I will need, where shall I put this? I'll put it here. Right, so I have the numbers there. What I will have to do, I will just have to pour half a liter here from the kettle, because I have 1000 ml in the kettle. There. And I boil this one up. And then, because I have half a liter here, so I'm not wasting any water. Right, I'm not pouring this away, because I need a total of 781 milliliters of tap water. So I just top this up until I reach that roughly. I don't know if you will be able to see it, but it's just below 800 mils. Right. So that is boiling. Yeah, it is lovely and boiled. Excellent. Let's add the tap water in. And then we will take a sample. Well, I will. Whew. So let's pour this in. Right. So there I have quite a lot of water. I have a mug here. It's a lovely mug. And let's put it there. And let's pour some of this water into the mug. Let the thermometer do its thing. Put it there and let's see if it will reach 50 degrees. Only if it would stay still. Oh, it's going up nicely. I don't know if you will be able to see that. Okay, it has reached 40. Mug was a little bit cold anyway, so let's just put a bit more water in. To see if it will go up. Because the mug was cold, so it can cool the water down. Trying to make it as stable as possible. It looks like it's stopped just between 40 and 50, so it's like 43 degrees. Right. Okay. That is not great. So I increase the temperature a little bit. Just a little bit. There. Let's pour this water away. I know this is a waste. I normally don't waste it, right? But I just want to make sure that the mug is warm enough. Let's see what happens now. Will it reach 50? Yeah, it has. There you go. It even went above 50. So the mug was cold. This is why you need to preheat the teaware, because the teaware can really cool it down. So this is why you preheat the teaware, and then you put the water in. Now it's stopped around 50 degrees. Yeah, there you go. That's 50 degrees, and I am going to make a brew. Let's do that. So I take this out. I don't need this anymore. After doing this for 15 minutes, we know that this is 50 degrees. Let's not waste this. Pour this in. There you go. Put the lid on. 2.5 minutes for the Jakuro, so I will set my timer to 2.5 roughly, because I don't know how much time I have wasted with this. There you go. So the thing is going there, timer, right, and I have this really fancy gong dai bay. Where there. I don't know if it will focus. It never focuses, does it? Oh, that's brilliant. Let's put it this way. Will it focus? That's the question, as always. There. So I have this gong dai bay. I got it because I just liked it. I like the color of it. It's nothing really fancy. It's just it's all of these are just coloring, so it's not rusty or whatsoever. There is no rust in it. Okay, so that's not no rust. This is purposely painted like this, and this is why I liked it. I really like the shape of it. Oh, this is crap. There. So I like the shape of it. Sorry, I'm hand holding the camera. So I like the shape of it. The only thing is, you pour one brew in, and it fills up quickly. If you put two brews in, it will be way up to the top, and because it heats up very well, I mean very well, it gets really hot. So you can't grab it, you can't touch it, because you will burn yourself. So you just put one brew in, and then you just pour it out, as you will see in a minute or so. Let's move that across. Move that across as well a little bit. I don't know. Or if I just do it, I will just hand hold it, the whole thing, and we will see how it turns out. So I have this fancy filter. It's a nice Chinese filter. It fits there perfectly. And I still have, how much do I have? I still have 5, 4, 3, 2, 1. Brewing is done. Excellent. So let's pour this out. Oh, come on, come out. Yeah, I'm trying to shake everything out so nothing stays in. Yeah, shake it out, eh? And put it there. That's how the leaves look like. That's Gioculo for you. And then shake that out. We are shaking everything out. That's the thing. So now I just grab it and pour it. And it's ready to drink. Brewed in 50 degrees water. It might have cooled down a little bit because the thing wasn't warmed up. But hi, this is how you do it in a scientific way. Or you just get a fancier kettle and whichever they can measure the temperature, and you just do it that way, I guess. I guess that's easier. But hey, this one is much more fun. We only spent 20 to 30 minutes just to make one brew. Yay! I see you later. Bye!